Ever looked up at the moon and wondered about all those bumps and holes? It's, right there most
Yeah,
nights.
it's such a familiar sight.
But have you ever really stopped to think why it looks like that? Why so many craters?
Exactly.
So, today on the deep dive, that's our question. We've got this really interesting written source that kind of digs into it.
It does, yeah. Takes us from the basics to some pretty intriguing ideas.
Right. Our mission then is to go beyond just rocks hit it and see what else might be going on based on this source.
Okay, so first up, the source covers let's call it the textbook explanation.
The standard story.
Yeah, billions of years, meteors, asteroids, just constantly bombarding the moon. And the key thing is, unlike Earth, the moon has basically no atmosphere.
Nothing to burn them up.
Nothing. So wham! They hit the surface, leave a crater. That definitely explains why there are craters and so many of them.
Okay, simple enough, but when you actually look, the craters aren't all the same, are they? Some are huge, some small, some deep, some shallow. Precisely. And that's where our source starts pushing a bit deeper. It raises questions. Why the variation?
It made me think, it can't just be about things hitting it. The source implies the way they hit, or maybe what the moon itself was like, must matter too.
Right, absolutely.
Hmm.
Think about the energy involved. A massive asteroid hitting at high speed, that's going to leave a very different mark than something smaller or slower.
Sure.
But the source also nudges us to think about the moon's surface itself. Was it always this solid, cold rock?
Good point.
Could early volcanic activity, maybe billions of years ago, have meant the surface was softer in places? Perhaps some impacts punched into mushier stuff, leaving shallower features?
Interesting. So not just the impactor, but the impactee as well.
Exactly. These are the kinds of, complexities that go beyond that simple rocks hit it idea.
And it wasn't all just way back then, was it? I mean, the source mentions newer craters too.
Oh, yeah. That's a key point. Cratering is an ongoing process, even now. Small impacts happen all the time.
But the source talked about cosmic eras of destruction. That sounds intense.
Well, it suggests there might have been periods in the solar system's history when things were, let's say, much more chaotic.
Mhm.
Maybe massive collisions elsewhere sent huge amounts of debris flying through the inner solar system.
Like a shooting gallery.
Sort of, yeah. Imagine the moon passing through clouds of that debris. That could explain clusters of craters from specific periods.
Wow. Okay, so comparing this to Earth really highlights something, doesn't it?
It really does. Earth is alive, geologically speaking. We have plate tectonics constantly recycling the crust, mountains rising, erosion washing things away, volcanoes paving over stuff.
Wiping the slate clean, basically.
Pretty much. Our planet erases most of its impact history over time.
Mhm.
But the moon, it's largely inactive. No weather, no significant erosion, very little geological churning.
So it just sits there.
And collects scars. It's like this incredible museum preserving the record of impacts going back billions of years.
Mhm.
Each crater is almost like a snapshot.
A snapshot of violence, mostly.
Well, yes, cosmic violence.
Yeah.
But it's a record nonetheless.
Which brings us to some of the more out there ideas the source touches on briefly.
Ah, right. The fringe theories.
Yeah, things like the moon maybe not forming the way we generally think, or perhaps being shaped alongside Earth by some shared massive events very early on. The source even hints at, well, otherworldly explanations.
And it's important to be clear here, as the source itself implies. These are fringe ideas. Mainstream science operates on evidence, and currently, these more unconventional hypotheses don't have strong supporting evidence.
Right, not widely accepted?
Not within the scientific consensus, no.
Ah.
But the fact that people think about these things, even on the edges, shows we're still trying to piece together the moon's complete story. There's still mysteries.
So looking at that cratered face isn't just seeing damage, it's like reading a history book.
A cosmic diary? Maybe. Written in impact craters. It tells the story of the solar system's formation, its chaotic youth, and ongoing events.
It definitely puts our own planet's history and its relative calmness now into perspective.
Absolutely. So here's something to think about next time you see the moon up there.
Okay.
Consider those craters not just as holes, but as clues. What other stories might they be holding? What unexpected twists in the solar system's past could be etched onto that surface, just waiting for us to figure them out?